Hello, today I'm going to briefly explain with the aid of diagrams why transition metal lines in solutions are colored. Firstly, a transition metal is located in the middle block of the periodic table, which is the block highlighted in green in the diagram. What makes it a transition metal is that it can form ions with its partially filled d subshells. When we add a transition metal ion to a solution such as water, it forms a complex where the central metal ion, in this case, which is iron, is surrounded by ligands, which in this case would be aqua ligands. As you can see, the water is surrounding the central metal ion, which is iron. When these ligands approach the transition metal ion in solution, it causes its d subshell to split into two different energy levels. The electrons at the bottom energy level can be excited to a higher energy level if the right frequency of light is absorbed. This is because the energy gap corresponds to an energy equals E equals hf, as you can see from the diagram, where h is Planck's constant and f is frequency, and therefore it means that the correct frequency of light must be absorbed for the electrons to be excited. Depending on which particular frequency of light is absorbed, we will see a different color. The color we see is the complementary color, or just white light minus the frequency of light absorbed. From this information, we can deduce that the color of solution is dependent on not only the transition metal ion itself, but also what type of ligand surrounds the ion, as it will affect by how much the d orbital splits and what frequency of light is absorbed, and therefore what frequency of light will be emitted.